Can we make sense of these results? So I basically have two results on the whiteboard, that the sum from n equals 0 to infinity of binomial 2 1 choose n is equals to minus 1 by root 3 times I. Notice that there's this thing called I, which is so absurd. And the another result is sum from n equals 0 to infinity of alternating series 2n choose n is 1 by root 5. So first of all, let me show you like how I actually got these results, and then we will discuss more. Okay, so if you try to find a series expansion for this function, 1 by square root of 1 minus x. If you try to find this, I'm sorry for this is worse handwriting. Okay, 1 by square root of with 1 minus x. Now, how you can find this is use the thing that the generalized binomial theorem given by Newton, that for any power it actually works to use the binomial expansion, and this will be equal to sum from n equals to 0 to infinity of minus half choose n and then minus x to the power n. It's the generalized binomial expansion. Yeah, and notice that this goes from 0 to infinity, unlike the normal expansion. Now, how do we find the value of this? We know that how to like break combinations or binomial thing as such. What we do is we write n such expressions: minus 1 by 2, minus 1 by 2 minus 1, minus 1 by 2 minus 2, up to minus 1 by 2 minus n minus 1, minus 1 by 2 minus n minus 1. So there are basically n expressions divided by n factorial, and then this is minus x minus 1 to the power n, x to the power n, right? Okay, so now for this one, what I can try to do is we can see that since there are n expressions, there will be n negative ones coming out from the brackets from all the over place. So minus 1 to the power n, and this will just be 1, and then minus 1 minus 2 is just 3, minus 1 minus 4 is just 5, 7, up to this is minus 1 minus 2n plus 1, that is minus 2n minus 1. So that's okay, wait, minus 1 minus 2n plus 1, sorry, plus 2. So minus 2n plus 1, that means 2n minus 1 over here. Yeah, and since there are like n 2's over here, I will have 2 to the power n, and then this is minus 1 to the power n, x to the power n, right? Now since there are like 2 minus 1 to the power n's, we can just write them in single expression. So we will have minus 1 to the power 2n, and for this one what I can do is I can introduce all these numbers in between, 2 3 4 5 6, all these numbers in between and up to 2n. And over here we know that these numbers 2 times 4 times 6 up to 2n, this is just there are n 2's which are multiplied by the n factorial, right? Also I forgot this n factorial over here. Okay, now over here there are in this 2 4 6 8 10 up to 2n, there are n 2's multiplied by n factorial, right? Because this is 2 into 1, 2 into 2, 2 into 3, 2 into 4, so n 2's and 1 2 3 4, so that's why we got this expression. Over here I have x to the power n. Now this is minus 1 to the power 2n, that will just be positive 1 because that's even power. And over here we have 2n factorial divided by this is n factorial, and x to the power n divided by 4 to the power n, right? And 2n factorial, n factorial, n factorial is just binomial 2n and n, that means 2n choose n, and this is x by 4 to the power n. So this is our 1 minus x to the power minus n. Notice that this only converges if the modulus of x is less than 1. This is a fact for the binomial series and of this kind. Also, if you want to derive this, just use the ratio test over here in this series expansion, and that will give you. If you use ratio test, you will just get what will you get? You will just get 2n factorial. Sorry, 2n plus 2 factorial. We actually have to test the modulus of a n plus nth term by nth term, right? So what will you get is 2n plus 2 factorial by n plus 1 factorial, n plus 1 factorial, divided by, and also there's x by 4 to the power n plus 1, yeah, and 2n factorial by n factorial, and there's x by 4 to the power n. We have to find the ratio as n goes to infinity, and for it to converge, the ratio should be less than 1, right? Now notice that at infinity, what will we have? So limit n goes to infinity. First of all, let's cancel these things. We will just have 2n plus 1, 2n plus 2. If we cancel that with 2n factorial, denominator we will have n plus 1, n plus 1, right? Yeah. And then over here we will just have x by 4. That should be less than 1. And then limit n goes to infinity. Limit n goes to infinity. We can take 2 common, so if that will be 4 common, right? And then n plus half, n plus 1 divided by n plus 1, n plus 1. And please note that at infinity, n plus k and these two are same at infinity, because this k is a finite number, and like comparing to infinite number, the finite number is way lesser. X by 4 is less than 1, and the 4 cancels out. These will also cancel each other out. So we see that if the modulus of x is less than 1, and then only the series will converge, right? Okay, so we have the series for this thing, and this will converge only if the x modulus of x is less than 1. Now what I'm going to do is, let us make substitution that y is x by 4, right? In that case, this will be 1 minus 4y to the power, wait, this is not from nth power, this is actually for minus half power, right? This is actually for minus half power, to the power minus half will be equals to the series sum from n equals to 0 to infinity to n, choose n of this is y to the power n now. So we see that the series, the function expansion for this wonderful series sum from n equals to 0 to infinity of 2n choose n x to the power n, for this wonderful series, this function is 1 by square root of 1 minus 4x, right? Which converges only if the modulus of 4x is less than 1. That means modulus of x is less than 1 by 4, correct? Yeah. So we know that we have this criteria for this for the series to be used, or the condition convergence condition. But if we try to break the rule, like if we just don't consider those things, and like if we just go straight forward, like how I'm trying to do is, for this series 1 minus 1 plus 1 minus 1 plus 1 minus 1, this is considered to be half, right? And how we get that? Just a by 1 minus r. First term is a, 1 minus our ratio is minus 1, so that's why 1 by 2. You get this, right? And since even though it's told that the ratio should be less than 1, the modulus of ratio should be less than 1, even though it's 1 we are using here and getting a value. And I know there are some people who are making sense of this result, though I cannot make sense of this result because this is actually diverging. But I have heard that there are people who make sense of this. So similarly, even though there is this convergence issue, I think that maybe people can make sense of this. So sorry that if you are expecting that I would make sense of this result, I would just tell you that yeah, we can get it. But let me see if you have any sense how this result is I mean, if you are even going beyond the convergence value, I mean the values that would make it converge, we would get some answers. Let's see. So if I put x as 1, sum from n equals to 0 to infinity of 2n choose n of 1 to the power n is just 1, and that gives us 1 by square root of 1 minus 4, that is 1 by square root of minus 3, that is 1 by square root of 3 times I, and if I goes in numerator, that will be minus 1 by square root of 3 times I. This is how I got the first value. Though I clearly know that we cannot substitute x as 1 because it is out of the bound, but yeah, if we do, we get this answer. And who knows, this might make some sense, but it's some mathematicians, I don't know. Okay, now again, next one is sum from n equals 0 to infinity to n choose n. If you just substitute x as minus 1 to the power n will be equal to, that will be 1 by square root of 1 plus 4, that will be 1 by square root of 5. And that's how we got the other answer. Yeah. And now, though these are not some correct values, now let's use some values that do make sense. We can use 1 by 10. Yeah. Okay, let's see if let's see how fast this series converges. If you use x as 1 by 10, if you want to find this value, sum from n equals to 0 to infinity of 2n choose n of 1 by 10 to the power n, we can use this series. That will be 1 by square root of 1 minus 4 by 10. That will be, let's use some good values. Let's use 16. So this is 16, and now this goes to numerator. 4 divided by square root of 16 minus 4 is 12. That is square root of 12. That is 4 by 2 root 3. That means 2 divided by root 3. We get this answer, right? And let me check what is the value of 2 by root 3 in the calculator. And the value is 2 divided by root 3. 1.1547. 1.1547. This is the answer. Let's check how long does it take for the original series to get to that answer. So first of all, 0 choose 0, 1 by 16 to the power 0, plus 2 choose 1, 1 by 16, plus 4 choose 2, 1 by 16 square. Let's see what is the value of this sum. First of all, 1 plus 2 times 1 by 16, which is 1.125. Already it's correct to one decimal place, plus 4 times 4 into 3 divided by 2 factorial times 1 by 256. Which is all okay. This is again up to this one. The answer is 1.148, which is correct to decimal place, right? If you round off. Next one is 6 choose 3, 1 by 16 cube. Let's see. Plus this is 6. Sorry. 6 into 5 into 4 divided by 3 into 2 into 1 and times 1 by 16 cube. It's almost there. We're almost there. It's around 1.1533, and we are really on 3, which is close. It's correct to 2 decimal place. So you see, even within the 4 terms, it's converging quite well. Yeah. Okay, yeah, this series works, but only works for the value that are under the convergence range. But yeah, we can find for even those which is diverging. Of course, clearly, if we just go on adding this, it's diverging, and this also because over here, since it is not, the values are getting smaller, but instead getting bigger, that will converge. I know, but yeah, just to look at the values, it's really a fun. Just like how we can get value for this sum as well using zeta function, and that's minus 1 by 12, and many people are surprised with this. This is just the misuse of the convergence, right? Yeah. Okay, so that's the moral of this story. Just be careful. But yeah, it's fun sometimes. And hope you enjoyed the video. Let me know if you have any idea how to make sense of this, and also let me know how do you actually know the rate of convergence. Is there any way to know the rate of convergence? How fast, how does slow it does converge? If you have, let's say in the comment section. I'll be happy to see what you guys have. Thanks for watching and look forward to seeing in the upcoming videos.